We will be talking about the new concept known as graphs. Okay. So let's see. So what do you mean by a graph? Today we'll be studying the 5th chapter known as graph. Is it audible and visible to everybody? Can anybody reply me? Nobody is replying. That means all of you have just switched on the mobile phone and you are leaving like that. Okay, if you don't listen, you are the sufferer. At the end of the day, you will be the sufferer. Okay, I will be getting my salary. Everything is okay. You will be the loser. Nobody is replying means nobody is listening my class. Okay. Okay. So today of data structure known as graph we will be studying. So graph is also one type of non-linear data structure. Say non-linear data structure. So linear data structures, what are the example? Arrays, linked list, stacks and queues. Non-linear, what are the examples? Trees and graphs. So I will be studying the graph theory. So it is also best example of non-linear data structure. So that you have to remember. So what is the difference between a tree and a graph? Tree is also having nodes, graph is also having nodes. Tree is also having edges, graph is also having edges. But a graph is nothing but a data structure in which all the edges are closed. A closed tree is a graph. A closed tree is nothing but a graph. A closed tree is nothing but a graph. So you can see a data structure that consists of a set of nodes and a set of edges that relate the nodes to each other. The set of edges describe the relationship among the vertices. A graph G is defined as G is equal to V of V. That is, V is a finite non-empty set of vertices, E of G set of edges. So you can see. So a graph is a closed tree. In tree, it was not closed, but in a graph, it was closed. So you can see. OE3, it is closed. 2, it is closed. So what are the vertices? 0, 1, 2, 3, 4. What is just 0, 1, 1, 2, 0, 3, 3, 0, 2, 2, 4, 2. So these are the pictures. So in this graph terminology, we will be studying a new thing known as adjacency, adjacent vertex, adjacent vertex. So what is adjacent to X? Y is adjacent to X. So X is adjacent to Y means Y is adjacent to X. So you can see here in this graph, who are the adjacent vertices? That is the vertices which are in one step, which are connected in one step, in one edge to the present vertex are known as adjacent vertex. So you can see. So from 0 to 1, in one step I can go, in one edge I can go. So it is 1 is adjacent to 0. From 0 to 3 also, in one step I can go. That is, in one edge only, I can reach the node 3. So you can see. So 0 is adjacent to 1, 1 is adjacent to 0, and 2 is adjacent to 1. So these are the adjacency vertices. So the adjacency vertex of 0 are 1 and 3, not 4 and 2. If I want to reach 4, how should I go? From 0 to 3 and from 3 to 4. So in two edges, I am going to, from 0 to, if I want to start at 0 and reach 4, I have to travel in two edges. So one is 0 to 3 and 3 to 4. Two edges I need. So two edges means it is not adjacent. Adjacency means what? Just neighbor. In one word, just neighbor. So if you take your home, your house, if you take your house, the just side house is known as adjacent house. There may be houses after your side house. Some after 2 or 3 houses, some houses may be there. There are not the adjacent houses. Adjacent means, in one word, just neighbor. The just neighbor house is known as adjacent house of our house. In the same way, the adjacent vertex of a given vertex is nothing but just neighbor of the given vertex. Just neighbor means what? In one edge, I have to reach the next vertex. So the adjacent vertex of 1 and 3, 0 are 1 and 3. The adjacent vertex of 1 is 0 and 2. So again, you can see here, it is a directed graph. See, from 0 to 1, I can go, but from 1 to 0, I can't go. So from 0 to 1, I can go in one step. So 1 is a 0. So 0 is adjacent to 1, but 1 is not adjacent to 0, because I can go from 0 to 1, but not from 1 to 0. 2 is adjacent from 1. 2 is adjacent from 1. So I can reach 2 from 1. Okay. So adjacent means neighbor. So in the same way, if you take 3, 2 are adjacent, 4 is adjacent, 0 is adjacent. Okay. So you can see. So adjacent means just a neighbor. Who is just neighbor? That is known as adjacent. So here I am having two types of graphs, directed and undirected. Directed means what? Has no orientation, no arrowhead. Directed means has an orientation, has an arrowhead. Undirected graph, all edges are undirected. Directed graph, all edges are directed. So you can see, and in undirected graph, all the edges will look like this. UV. In directed graph, all edges look like this. This arrow mark will be there for any edge. Here, they will not be there for, no edge will be there for these edges. So that is the difference. So in directed graph, all the nodes, all the edges should have an arrow. Whereas in undirected graph, no graph, no edge can have, no, there is no need for any edge to have an arrow. Okay. So see. So a graph in which every edge carries a value. So you can see here. So from Dallas to Washington, what's the distance? 1300. From Washington to Atlanta, 600. From Atlanta to Washington, 600. From Denver to Atlanta, 1400. So this number is the weight of the edge. That is the distance of that edge. That is the length of the edge. So edge is nothing but a line which connects the two nodes. And there are two types of edges. One is directed and one is undirected. So you can see Austin to Dallas 200, Dallas to Austin 200. So again, Dallas to Chicago 900, Chicago to Denver 100, Denver to Chicago 100, 1000, and again Austin to Houston 160, Denver to Atlanta 1400, Dallas to Denver 780. So like this. So you can see this is a real-time example, a graph which shows the connection of the different cities in the USA. Connection of different cities in the USA. The connection is nothing but in our words it is known as edge, and in edge is having some length. In other words, we can call it as weight also. So in this real world example, each edge gives the length of the distance between the two nodes, two cities, any two cities, distance between any two cities. So you can see the directed edge also. See, it is direct from Dallas to Washington. If you take the edge is directed to Dallas, that means I can reach from Washington to Dallas, but I can't go from Dallas to Washington. Okay, that's the. So here also Dallas to Denver, but I can't move from Denver to Dallas. So you can see. So directed graph, undirected graph. So you can see directed graph. You can see this one, undirected graph. So there are no arrows here. Here there are no arrows. Here there are arrows. So you can see the graph terminology. Adjacent nodes. Two nodes are adjacent if they are connected by an edge path. A sequence of vertices that connect two nodes in a graph. So a sequence of vertices. So okay, next one. A simple path is a path in which all vertices except possible in the first and last are different. Complete graph, a graph in which every vertex is directly connected to every other vertex. So that's the. So here in this example, we'll see. A cycle is a simple path which the start small, same start and end, which will have the same start and end vertex. The degree of the vertex I is the number of edges incident on vertex I. Okay. So for example, what he is telling, degree of 2, degree of 2 here you can see. Degree of 2 is 2 because two edges are connected to it one. So again, degree of 5 is 3 because three edges are connected to 5. Degree of 3 is 1. Okay. So you can see here. Undirected graph are connected if there is a path between any two vertices. So you can see here. Directed graph are strongly connected if there is a path from one vertex to any another vertex. Directed graphs are weakly connected if there is a path between any two vertices ignoring the direction. A complete graph has an edge between every pair of vertices. So you can see the examples. By definition, you can tell here. Undirected graphs are connected if there is a path between any two vertex. So path means what? See, in this example. See, I want to reach 3 from 1. The path is 1, 2, 5, 3. So this is the path. So path means what? It is a collection of edges, collection of vertices from the starting node to the end node. So you can see the definition here. Path, a sequence of vertices that connect two nodes in a graph, a sequence of vertices and edges. So if you take the example of this one, 1 and 3. So what are the edges here? 1, 3, 3, 5, 5, 3. 1, 2, 2, 5, 5, 3. Three edges are there. So three edges are there. So it is a simple path. It is a path. A simple path is a path in which all vertices except possible in the first and last are different. All are different. Then it is a simple path. So in this example also you can see undirected graphs are connected if there is a path between any two vertices. So if I take any two vertices, if I can reach from one vertex to another vertex by using a path, then it is known as connected. Directed graphs are strongly connected if there is a path from any one vertex to another vertex. So here also directed is if there is a path from one vertex to another vertex, strongly connected if there is a path between one vertex to another vertex. Directed graphs are weakly connected. So In directed graph means what? There is a direction. Without the direction, I can't reach from one path to another. So when I will tell it is a weakly connected graph, directed graph, when I will call directed graphs as a weakly connected graph, when the two vertices, if there is a path between the two vertices, ignoring the direction. In directed graphs, we should consider the direction. It is compulsory. If we consider the direction compulsorily, then many paths will be vanished. So what he's telling is directed graphs are weakly connected if there is a path between any two vertices, ignoring the direction. If I ignore the direction and I can connect any two vertices, then it is a weakly connected. Fourth definition you can see. A complete graph has an edge between every pair of vertices. So there is not, it is not path, edge. So edge means what? One step. In one step, one node should be connected to another node. One vertex should be connected to another vertex in one step only, in one edge only. Then it is a complete graph. So you can see here. You can see the example. So all these nodes are connected in one step. So you can see here. You can see. In one step, they are connected. One vertex is connected to another vertex. You can see. So you can see path, a sequence of vertices that connected two nodes in a cycle is a simple path with the same start and end vertex. So you can see. So if I see, this is the path from 1 to 1. From 1 to 1, that is 1, 2, 5, 7, 6, 4, 1. 1, 2, 5, 7, 6, 4, 1. So it is a path. It is a cycle. It is a closed path. So here, first vertex and end vertex are same. So first vertex is 1, end vertex is 1. So it is a cycle from 1 to 3, 3 to 5, 5 to 7, 7 to 6, 6 to 4, 4 to 1. So it is a cycle. So in the same way, is there are any cycles? No, there are no cycles. Okay. So is there is any paths between 9 and 10? Yes, there is a path between 9 and 10. From 9 to 8, 8 to 11, 11 to 10. So that is a path. So these are the definitions. What are the definitions we have seen? See, adjacent nodes. What do you mean by adjacent node? What do you mean by path? What do you mean by simple path? What do you mean by complete graph? A graph in which every vertex is directly connected. Directly connected to means what? In one edge, I will be reaching the another vertex. From one vertex, I will be reaching the other vertex in one edge. A cycle is a simple path with the same start and end vertex. The degree of a vertex I is the number of edges incident on that I. So for example, if you take node, what is the degree? 2. See, because 2 edges are incident to that one. If we take 4, node 4, what's the degree? 2. If we take node 2, what is the degree? 2. If we take node 5, what's the degree? 3. If you take 7, what's the degree? 2, because 6, 7 and 5, 7, two nodes are there. If you take node 3, only one degree is 1, because only one edge is incident to that node. If you take 9, degree is 1 only. Degree of node 9 is 1 only, because one edge is connected only. If we take 8, node 8, two edges are there. If you take node 8, two edges are there. So the degree is 2. So if you take node 11, the degree is 2, because 8, 11, 11, 10, two edges are there. If you take node 10, one edge is there, that is 11, 10, one is there. So in degree is 1. So that's the degree. So only one cycle is possible in this graph, that is from 1 to 2, 5 to 7, 7 to 6, 4, 6 to 4, 4 to 1. So path means a bunch of, that's the main thing. That's the main thing you have to remember. a sequence of vertices and edges that connect any two nodes in a graph. So that connect any two nodes of a graph. So for any two nodes, 1 and 7, if you take, two paths are there from 1 to 4, 4 to 6, 6 to 7, or from 1 to 2, 2 to 5, and 5 to 7. Two paths are there. So in this way, I will be having two paths. If you take 1 to 3, for example, I will be having two paths: 1 4, 4 5, 4 6, 6 7, 6 5, 5 3. And another path is 1 2, 2 5, 5 3. So these are the two paths. So some other definitions. Previously, we had read the definition known as cycle. The cycle definition and the loop definition are the same. Here, see, loops means what? Edges that connect a vertex to itself is nothing but a loop. Path, sequence of vertices P0, P1 up to Pm such that each adjacent pair of vertices are connected by an edge. So I will start at P0 and end with Pm. I will start at P0 and travel and reach Pm, point M. In between one, there are number of edges. So each edge is known as P0, P1, P1, P2, P2, P3, like that. Okay. So next one. A simple path is a path in which all vertices except possible in the first and last are different. Multiple edges. Two nodes may be connected by greater than one edge. Okay. Loops. Edges that connect a vertex to itself is known as loop. So you can see here, example. 1 minute. Here, no, nothing is there. So you can see here. What do you mean by loop means? Example. So this is a loop. There is a loop in vertex 2. A edge starting and ending of that edge is the same vertex. That is known as loop. So that's it. So 2 is the loop. Second. Loop means edges that connect a vertex to itself. Paths means sequence of vertices P0, P1 up to Pm such that each adjacent pair of vertices are connected by an edge. A simple path is a path in which all vertices except possible in the first and last are different. Multiple edges. Two nodes may be connected by greater than one edge. Simple graph has no loops and no multiple edges. So loops means edges that connect a vertex to itself. Path means sequence of vertices such that each adjacent pair of vertices are connected by an edge. So simple path means it is nothing but a cycle. It is not a cycle. So here first and last nodes are different. That is known as simple path. If first and last nodes are same, then it is a cycle. Okay. So multiple edges means two nodes may be connected by greater than one edge. So I will show the example here. So you can see 0 and 3, they are connected by more than one edge. So that is known as multiple edge. All this terminology first you have to know to understand the next things in this unit 5, that is known as graph theory. So you can see number of edges in an undirected graph. The number of possible pairs in an n vertex pair is n star n minus 1. Since edge UV is the same as edge VU, the number of edges is an undirected graph in n star n minus 1 by 2. So if I am having how many edges here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 vertices I am having. That's what now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 vertices I am having. So maximum possible pair of what we call edges is n star n minus 1. If there are n vertices in a graph, maximum possible edges is n star n minus 1. So if we take as since edge UV is the same as edge VU, the number of edges in an undirected graph is n star n minus 1 by 2. Actually, the total number of what we call edges are n star n minus 1. That's okay. But what he is telling, he is taking the duplicates. That is, if it is an undirected graph, then UV is same as VU. That is, AB is same as BA. If it is a directed graph, then AB is different from BA, or 1A is different from A1. But it is a directed graph, but with an undirected graph, AB is same as BA. So he is taking the duplicates. Then how many will be there? N star n minus 1 by 2 will be. Here also the same. So if we take directed graph, then here see AB is different. If you take the edges, AB is different from BA. There may be edge AB, but here see in this example BA is not there. AB is there, but BA is not there. So I will consider AB as a different edge and BA as a different edge. Then what are the possible number of edges here? N star n minus 1. So here see the number of possible pairs in a vertex n vertex graph is n star n minus 1. Since edge UV is not the same as edge VU, that you have to understand. That's the main point. The number of edges in a directed graph is n star n minus 1. So, but in a undirected graph, n star n minus 1, UV is different. UV is same as VU in undirected graph. In undirected graph, UV is different. UV is same as VU. That's why I will halfen the number of values. That is n star n minus 1 by 2. I will be writing like that one. So possible pair of vertices or number of edges will be n star n minus 1 by 2. So here you can see the if we take what we call uh, undirected graph, there is one word known as degree. If I take directed graph, there will be two words known as in degree and out degree. In degree of a vertex I is the number of edges incident to I. So if you take in degree of 2, what is in degree of 2? Only 1, because the number of edges coming into that node is 1 only. Okay. In degree of 8, if we take in degree of 8, if we take this one, 0, because the number of edges coming into that vertex is 0. Out degree. So out degree of I is the number of edges incident from I. So out degree of 2 is 1, because the number of edges going from 2 to 5 is 1. Out degree of 8 is 2, because from 8 how many edges are going outside? 2 are going outside. So now to represent the possible edges and for computational purpose, this type of graphs are understood by humans. If I write like this graph, this may be understood by humans, but the computer can't understand these graphs. So the computer, how it will take the input for a related to a graph, it will take as lists or matrices. Adjacent matrix will tell the possibility of a graph, which edges are connected directly, which vertices are connected directly, which are not directed connectedly, which edge is there from one node to another node, like that. So you can see the example. So adjacency matrix is a square grid of Boolean values. If a graph contains n vertices, then the grid contains n rows and n columns. For two vertices numbered I and j, the elements at row I and column j is true if there is an edge from I to j, otherwise false. So if we take for two vertices numbered I and j, the element I and the row I and column j is true if there is an edge from I to j. So that's the thing. You can see here, adjacency matrix. So for example, take the matrix here: 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. From 0 to 0, nothing is there, so false. From 0 to 2, 1 is there, so true. From 0 to 1, false, because there is no direct edge. Adjacency matrix means what? If there is only direct edge from between any two nodes, if you take any two nodes, there may be a path, but I don't want path. I want direct edge. See, if we take from 0 to 1, there is a path from 0 to 2 and 2 to 1, but there is no edge. But there is no edge, direct edge. So adjacency matrix means one adjacency matrix, each value will be 1 or true when there is a direct node between any two vertices. There is only one edge between any two vertices, then it will be true. There may be a path, there may be, I can reach from one vertex to another vertex in 2 or 3 edges. Then it is not that, it will not come under adjacency matrix, it will come under path matrix. It is a different one. So now we'll study this one. See, from 0 to 0, nothing is there. From 0, false. 0 to 1, 0 to 1, see, there is a path from 0 to 2 and 2 to 1, but there is no direct edge, so false again. From 0 to 2, there is a direct edge, only one edge, so it is true. You can see here. From 0 to 3, from 0 to 3, 0 to 3, I can go from 0 to 2, 2 to 1, 1 to 3, but there is no direct edge, so it is false. So again, 0 to 4, you can see 0 to 2, 2 to 1, 1 to 3, 3 to 4. It is also false. Again, see 1 to 0, 1 to 0. There is no direct edge, so false. 1 to 1 is false. 1 to 2, false. 1 to 3, true. See, 1 to 3, it is true because in one edge only I can reach from 1 to 3. So it is true. So you can see here. This is true. This is true. So true is exception here. From 1 to 4, I can't reach directly. I can reach from somewhere from 1 to 3, but 3 to 4 also there is no directed edge. There is an edge, but the edge is from 4 to 3. I can move from 4 to 3, but I can't go from 3 to 4 because the arrow is pointing to 3. So it is one directed edge. So one directed edge tells means what it tells, I can reach from 4 to 3, but not 3 to 4. So that's the thing. So I can reach from 1 to 4. So I can't reach from 1 to 4. So 1 to 3, 1 to no, 3 kada? Okay, from 3 to 0, no, I can't go. 3 to 1, I can't go. 3 to 1, see, it is a direct next, what we call next node only, but the edge is not pointing towards 1. From 1 to 3 edge is there, but no 3 to 1. So you can see here. So 3 to 0, 3 to 1, 3 to 2, 3 to 3, 3 to. So again, 3 to 3, nothing is there. 3 to 4, also see 3 to 4. 4 is also next. In one edge I can reach 4, but the direction is not there. From 4 to 3 is there, from 3 to 4 it's not there. So it is also false. Next. From if you take 4, node 4. From 4 to 0, no, nothing is there. So false. 4 to 1, nothing is there, false. From 4 to 2, that, see 4 to 2, if you take it is also in one edge I can move from 4 to 2, but the direction is not like that. From 2 to 4 is there, the direction. From 4 to 2, no direction is there, so I can't reach there. So it is false. So 4 to 3 I can go. So see here, from 4 to 3, because the direction is towards 3, so it is true. 4 to 4, false. So this is the adjacency matrix. First, to do any algorithm in a graph data structure by using graph data structure, the basic data structure which we have to build is adjacency matrix like this. False means 0, true means 1. First thing what I have to do anything in a graph data structure, I should build the adjacent matrix. The basic component of graph data structure is adjacency matrix, because this adjacency matrix only tells what the graph look like. See, this diagram a human can understand, but the computer can't understand. The computer can understand only this adjacency matrix. By using this adjacency matrix, it will know which vertex is adjacent to which vertex is just in one step to another vertex. So the same thing it was written. So you can see 1 to 1 0, 1 to, see, it is an undirected graph. Previously it is a directed graph. Here it is an undirected graph. See, here 1 to 2 and 2 to 1 are same. So 1 to 1 0, 1 to 2 1, 1 to 3 1, 1 to 4 1, 1 to 5. See, 1 to 5, there are, to go to 5, I have to take 3 steps, 2 steps at least. See, 1 3 5 or 1 4 5 or 1 4 3 5 or 1 3 4 5. So 4 possibilities or 5 possibilities I can go, but in one edge I can't go. In one edge I can't go. That's why it is known as 0. From 2 to 1, it is also 1. From 2 to 2, 0. So 2 to 3, 0. See, 2 to 3. From 2 to 3, I can go from 2 to 3, but there is no one edge for going from 2 to 3. So it is 1. It is 0. 2 to 4, 0 or 1. So from 2 to 4, there is a direct edge. So it is 1. 2 to 5, it is 0. So in 2 steps or 3 steps, I can reach from 2 to 5. That's why it is 0. So again, if you take 3 to 1, it is 1. 3 to 1 in one step only, direct edge is there. So it is 1. Next, 3 to 2 in 2 steps. So it is 0. 3 to 3, it is also 0. 3 to 4, in one step I can go. In 3 to 5, in one step I can go from 3 to 5. So it, from 4 to 1, one step. From 4 to 2, one step. From 4 to 3, one step. From 4 to 4, 0. 4 to 5 in one step. See here. So all once again. See, from 5 to 1, from 5 to 1 I can go, but in 2 or 3 steps. So it is not adjacent. So it is, I have got 0. From 2 to 5 to 2, in 2 steps I can go, but in one step only I need. So it is 0. 5 to 3, one step. 5 to 4, one step. 5 to 5, 0. So again, you can see the adjacency matrix of a directed graph. This is an multi-graphs, the adjacency matrix only. So here you can see 1 to 2. In 3 ways I can go. That's why it is known as 3. 3 adjacent edges are there. That's why he has written 3. This is also one type of representation. But the main representation is this one only, 0 and 1. This adjacency matrix in zeros and ones, it is the basic component of graph data structure. First, you have to write this one. You should know how to write this adjacency matrix. Then everything will be followed. So adjacency list representation. It is also one type of representing the graph. The system can understand by using the matrix or the adjacency list. So you can see here, who is adjacent to 1, 2 and 3. So 2 and 3. So that is the list. If it will take an array, ADJ of 1, 2 and 3, ADJ of 2, 3. What are the adjacent to 2? Only 3 is there. From 2 to 3 only I can go. From 2 to 1 I can't go. So 3 is adjacent to 2. So 3 is kept. Adjacent to 3, nothing is there. All are incoming only. No outgoing edges there. So nothing. Adjacent to 4. So I can go to 4. So adjacent. So it is nothing but the. So this is also, you can see an example of implementation of a adjacency matrix for a big matrix. Big directed graph matrix is like this. First you have to practice writing this adjacency matrices. Then only you can understand the things. And adjacency list. So this is the adjacency list represented in linked list rather than representing in a array. So any list can be represented in 2 ways. One is array and another one is linked list. This is one type of representation of adjacency list. So previously I told, system can understand the graph, the given graph diagram in 2 ways. One is adjacency list and adjacency matrix. In adjacency list, there are 2 types. One is representing in arrays, another is representing in linked list. So these are the very, very basic things that you have to understand in a graph theory. So what are the basic things you have to understand? This adjacency matrix representation, adjacency list representation. So these 2 things you understand. So in general, we don't use adjacency list. In general, we use adjacency matrix. So adjacency matrix representation, first you have to know perfectly in a graph. So then you can understand everything. And also these definitions you have to understand. What do you mean by degree? What do you mean by path? What do you mean by simple path? What do you mean by directed edge? What do you mean undirected? All these things. Okay. So today we will be stopping this class. Okay. So if you have any doubts, we will see. I think the timetable is changed. In the 4th hour, we will be having a virtual lab. Try to install the C compiler on your system, or try to connect to any online C compiler. Today we will try to execute 1 or 2 lab programs. Okay, in the 4th hour. All the YouTube videos will be shared now. See, maximum YouTube videos are shared. Some 3 or 4 are pending. That I will anyway I will upload now. Okay. Okay. Today I will be stopping the class. So in the 4th hour, if possible, we will execute 1 or 2 programs that in the lab manual. So try to install any C compiler in your system, or you can directly go to the online C compiler and execute there. Okay. Okay. Any doubt? C compiler. See, if you search in the Google C compiler, Turbo C compiler, you will get the small exe file. You try it. Turbo C compiler. If you type on the Google, you will get a small exe file. Try to install that one. Then automatically C compiler will be installed. Okay.